In this lesson, we'll look at measurement and we'll be starting with using and converting metric lengths. Our learning intentions is to be able to convert between metric lengths, for example, kilometers, meters, centimeters, and millimeters, and also to be able to read a length as shown on a ruler or a tape measure. And our criteria for success will be that we can convert between those four measurements, and also that we can read measurements from a metric ruler. The key ideas today that the meter, which we represent with the M, is the basic metric unit of measurement. So again, this is in the metric system. So 1 kilometer, represented by km, is equal to 1,000 meters. 1 meter is equal to 100 centimeters, and 1 centimeter is equal to 10 millimeters. And these are the four basic measurement units that we'll be using. When we need to convert between those four measurement units, we convert from a smaller unit, to a smaller unit, we multiply by a power of 10, i.e. 10, 100, or 1000. Now, if we're going from a smaller unit, to a smaller unit, we're going to need more of them to represent the same space, so it makes sense that we would be multiplying. Now, we can represent this conversion with a fairly straightforward graphic. So here we have our kilometers, meters, centimeters, and millimeters in order from largest to smallest, left to right. And we can see how that conversion happens. So if we want to go from kilometers to meters, we will multiply the number by 1,000 because there are 1,000 meters in a kilometer. From meters to centimeters, we multiply by 100. And from centimeters to meters, we multiply by 10. So we can see a clear multiplication by powers of 10 if we want to go from a larger unit to a smaller unit. Now, if we're converting to a larger unit, we will divide by powers of 10. So again, a larger unit means that we need less of them to take up the same space. So again, it makes sense that we divide. So in a similar way, if we look at our conversion graphic, to go from millimeters, a small unit, to centimeters, which is a bigger unit, we will divide by 10. From centimeters to meters, we will divide by 100, and from meters to kilometers, we'll divide by 1,000. We can also draw this graphic in different ways to go straight from kilometers to millimeters and so forth. When we're reading measurements from a ruler or a tape measure, there's a few things we want to consider. First of all, we need to be sure about the scale that the device is showing. So in this example here, it's a part of a ruler. It is showing both millimeters and centimeters. Often your device will show this. Sometimes you'll have to know by looking at the scale what it represents. Sometimes the position 0 or the 0 mark of your device is the edge of the ruler or the device, and sometimes, like in this case, there is actually a 0 position ruler mark. So again, it's very important that you don't accidentally use the end of a ruler if there is actually a 0 position. Make sure you know which device you're using. These larger marks are the centimeter markings for this ruler. So usually the largest scale represented will be the largest marks on the ruler. We then go down to the millimeter marks. So we can see that there are 10 millimeter markings between this 1 and 2 centimeters. And that is good because we know that there are 10 millimeters in 1 centimeter. We often also have a 5 millimeter marking, the middle mark between each centimeter, and that helps us to often see that it's easier to read. So again, what I was saying before is we often have the largest mark on the ruler as being the largest distance measurement, so 1 centimeter going to 2 centimeters. The next largest mark on this ruler is the half centimeter or 5 millimeters, and then we go down to the smallest unit of measurement being the smallest marks, which is the individual millimeters. So let's have an example of how to actually read something. So if we have this line here, we can break that line down into different sections. So we'll start with our full centimeters. So if we have a look, we see that there is the 0 mark. It's starting from the 0, and the largest full centimeter that it goes to is the 3. So that position there is 3 centimeters, or it can also be said to be 30 millimeters. The next gap that we have, or next largest measurement we have, goes up to the half centimeter, so that 5 millimeters. And that's easy to see because of that slightly bigger line. So that little part of the measurement can be said to be 5 millimeters, or 0.5 of a centimeter. And the last bit we have is from where we just measured to that half centimeter, going 3 more individual millimeters, and that can be said to be 3 millimeters of distance, or 0.3 of a centimeter. So if we were to put all those together, we could say that that whole distance represented here is 30 millimeters plus 5 more millimeters plus 3 more millimeters, which gives us a total of 38 millimeters. Or we could also say it is 3 centimeters plus 0.5 centimeters plus 0.3 centimeters, which gives us 3.8 centimeters. So 38 millimeters or 3.8 centimeters are equivalent distances. Now, you don't normally need to break it up like I have here. If you can look at that and read it, that's fine. But when you're reading it, you'll generally do those steps in your head. You'll find the biggest number, then go down to the next smallest distance, then go to the next smallest distance again, and you'll add them up in your head to get those distances and therefore get the overall measurement. Okay, it's time to go off and do the questions. You can follow on next for examples of how to do the questions, or suggested that you actually go and try them first and just come back and watch this if you need to. So the first question you do is actually question 2, and asks you to convert the measurements shown into the ones in the brackets. So A is saying 2m, which is 2 meters, into centimeters. And J here is saying 0.02 kilometers into meters. So it might help to have our little graphic to represent how we convert. So let's throw that up here. So we can see if we want to go from meters to centimeters, we're going to multiply by 100. Now, hopefully you've already done some work on how to multiply by powers of 10. So if we had the number 2, which is our 2 meters, and we want to multiply by 100, we know that we simply add those 2 zeros of the 100 onto this. So we can actually say that 2 meters is equal to the 2 plus 2 zeros on from the multiplied by 100, and we now put our centimeters in. So 2 meters is equal to 200 centimeters. Here we have 0.02 in kilometers, and we want to go to meters. So we're going to multiply by a power of 10, which in this case is 1000. So again, if we're multiplying a decimal by a power of 10, we know that we can just move the decimal place. And in the case of multiplication, we are going to move it to the right. So here we go. We're going to move 1 spot, 2 spot, and we don't have a 0, so let's chuck 1 in there and then go to a 3rd spot here. Okay. So now what we have is 0.02 kilometers is equal to 20 meters. So our decimal point was here at the end. Technically there's a 0 there. We don't need to show any more, and that's what we want. 20 meters is 0.02 kilometers. Question 3 says to add these lengths together and then give the result in the unit that is shown in the brackets. So there's 2 stages to this. The first thing is to add these 2 distances together and then convert them into this unit here. But what we can see is that we have one of them in centimeters and one of them in millimeters. So we actually need to convert some of these first before we go ahead and add them, because you can't just add that 5 and 2 together because they have different units. The smart thing to do is to look at what we want the answer to be. So we want the answer to be centimeters. So our first measurement's already in centimeters, so let's just keep that. But what we want to now do is convert the 5 millimeters into centimeters as well, so we can just do an easy addition. So let's throw up our graphic. So we want to go from millimeters to centimeters, so we're going to be now dividing by a power of 10. So if we have a look, we go 5 millimeters. Now we know that if we want to divide by 10, we move the decimal point to the left. So remember, this 5 is really the same as saying 5.0. So to move the decimal place to the left, we are going to move one spot divided by a power of 10. So it's going to go here, and we can put a 0 at the front just to make it look better. So 5 millimeters is actually equal to 0.5 centimeters. Okay, don't forget to change the unit of measurement. So now we have a simple equation of 0.5 plus 2. We'll put a 0.0 just to keep everything lined up. If we do our simple addition, we have the 5, the decimal point stays lined up, and the 2. So our final answer is this is equal to 2.5 centimeters. Not forgetting the correct unit of measurement that the questions asked for in the brackets there. Same thing for E, 6 kilometers plus 200 meters. Now we want to be in meters. This one is already in meters, so let's convert our 6 kilometers into meters. So if we look at our diagram, kilometers into meters means multiplying by 1,000. So that really just means adding 3 zeros on. So 6 kilometers becomes 6,000 meters. So again, we now have a simple addition to do. So we have 6,000 plus 200. Again, making sure we keep everything lined up. There's no decimal places in this case. And this is a pretty obvious one, 0, 0, 2, and 6. All right, so our final answer is equal to 6,200 meters. So again, the first step is to convert one or both into a common unit, and where you can convert them into the unit that you want the answer to be in. And then once you've got them in a common unit, it's very easy to add them up. Question 4 says to convert these units into the shown bracket again. The difference will be when we look at our graphic, we can see that we're going from meters in this case to millimeters for A. We're actually jumping 2 spots. So we want to multiply by a factor of 10. But if we look at it, we're going to multiply first by 100 to get to centimeters, and then we're going to multiply by 10 again to get to millimeters. Now, if we're smart about this, we can say, well, that's actually the same as multiplying by 1,000. So we can do this very, very easily. So we're going to have our 3 technically multiplied by 1,000, which we know is easy just to add the zeros on. So it's going to be 3,000 millimeters. For the second one, we're going from 47,000 centimeters into kilometers. So again, we're jumping 2 places here, going from centimeters through millimeters into kilometers. So we would normally divide by 100 to get to millimeters, and then divide by 1,000 to get to kilometers. But again, we know that we can do that in one step. We can actually divide that by 100,000, which really just means moving the decimal point by 5 zeros. So if we have 47,000, remember technically that means a decimal point's here. Okay, we're going to move it by 5 zeros in total. So we're going to go 1, 2, 3, 4, 5. So the decimal point actually comes at the front here. So we'll put a 0 just to make it clear. So that is actually equal to 0.47. We don't need all these extra zeros, but we do need to put the unit of measurement in. So 0.47 kilometers is the same as 47,000 centimeters. Question 5, we're going to look at some measurements on the ruler. So we need to look at where they're starting from. So this first one, B, is starting from the 0 mark, so that's good. And it's coming up to this 5 centimeter mark. There's no additional millimeters added on, so this one is simply 5 centimeters. We could also technically say this in millimeters. It would be 50 millimeters. But if the question doesn't ask you for it, you usually want to try and show your measurement in the simplest form. So the simplest way here is 5 centimeters. For F, it's not starting at the 0 marker. It's actually starting at this marker here, which if we have a look is 1 centimeter and 5 millimeters. So it's starting at 1.5 centimeters. and it's coming up here to this point, which is 4 centimeters and another half or 5 millimeters. So it's coming up to 4.5 centimeters. So the distance in between here is the difference between 4.5 minus where it started from being 1.5 centimeters. Again, keep everything lined up when you're doing subtraction of decimals. So 5 from 5 is 0. Keep your decimal lined up. 1 from 4 is 3. So the distance of the arrow shown is 3 centimeters. Again, we could call this 30 millimeters, but really we want the simplest answer because it doesn't specify, so we'll go with 3 centimeters. And if we have a look at this, that would be correct. We're going 1 whole centimeter, 2 whole centimeters, 3 whole centimeters there. Now, question 10, we've moved into some worded problems. The construction engineers individually have plans to build the world's next tallest tower. The Titan Tower is going to be 1.12 kilometers tall. The Gigan Tower is to be 109,500 centimeters tall, and the Bigan Tower is to be 1,210 meters tall. So each one of these towers has been measured in 3 different measurement units. So we want to find out which one is going to be tallest. So the first thing is, of course, to convert them all into a common measurement unit. We have to think about what the most efficient way is. The simplest one would be 1.12 kilometers, but that doesn't give us a lot of definition if for just a little bit of a difference. So most towers, most buildings are measured in meters. So let's convert them all to meters. Technically, it wouldn't matter. Whatever you convert them to, they will all be equivalent. So you'll still be able to tell, but we're going to take the best option. So we can leave the Bigan Tower because that's already in meters. If we want to convert that one from 1.12 kilometers into meters, let's get our graphic again. So from kilometers into meters, we need to multiply by 1,000, which means adding 3 zeros. So we're going to have 1.12 kilometers is equal to 112. We'll put our 3 zeros. Okay, we still have to have the same number of decimal places, don't forget. So we need to have 2 decimal places. So it's equal to 1120 meters. Don't forget to have the correct unit. And the Gigan Tower is going to be 109,500 centimeters. To convert that to meters, we need to divide by 1,000. So we're going to have 109500. Dividing it by 1,000 means we're going to move the decimal place again by 2, but this time we're going to move it to the left. So if we just think about that's where the decimal point really is, we're going to move 2 decimal places to the left, 1, 2, that's there. So that's equal to 1095. Because these are all zeros past the decimal point, we won't bother showing it. But again, let's put the meters measurement unit in. So what we now have, technically, is this tower here is 1120 meters, and this tower here is 1095 meters. So if we were to put those in order, we have 1210 being the Bigan. I'm just going to put B above it. The Gigan Tower is 1095, so that is smaller, 1095. The Gigan, we'll put the G above that. And the last one we haven't shown is the Titan Tower, which was 1120. That's going to be in here, actually, 1120, which is the Titan Tower. So we can see in this case that the Bigan Tower is the biggest. So we have to still write a worded answer, though. So the tallest tower is the Bigan at 1210 meters. So that would be a suitable answer. Question 11 is another worded question. It says steel chain costs $8.20 per meter. How much does it cost to buy the chain length shown? So again, this is a situation where we have 2 different measurement units. We have something in centimeters and we have something in meters. So we need to convert one or both of those. So let's throw up our chart again. It's going to be easier to convert our centimetres into metres because our cost is in metres, and that's probably easier to do instead of trying to convert this cost into something different. So 70 centimetres into metres means dividing by 100, which means moving the decimal point. So 70 centimetres, if we just leave off the centimetre for a moment, is the same as putting a zero there, the decimal point, the zero. We're going to move the decimal point 2 spaces to the left, so it's going to end up here. So that is equal to 0.7. Again, we don't need to show the zeros because they're all zeros, so we can just leave it like that. So 0.7 metres. Okay, now that we've converted that into metres, we need to do an equation, and we're going to see how much of the $8.20 per metre is 0.7 metres. So what we'll do here is we'll multiply $8.20 by 0.7 metres. So we've got 0.7 metres we need to get, but it costs $8.20. To multiply decimals, we can start by just ignoring the decimal point. So we have 820 multiplied by 7. So 7 zeros are 0, 7 twos are 14, and 7 eights are 56, plus the 1 is 57. And now we add back in the decimal points. So we had 2 decimal points for the first number and 1 for the second number. So we need to have 3 decimal points shown. So we can't show it there, sorry, we shouldn't do that yet. And then we can say here 5.740. Now this is a multiplication of a dollar amount, so we have to put the dollar sign back in. And because it's dollars and because this is a 0 here, we don't want to actually show that. So we actually say it is equal to $5.74. So now we need to write that in a worded question though. So we can write 70 centimetres of chain will cost $5.74. Okay, so that's one way of doing that question. There are other ways you could get to it, but that's one way that we'll look at in this case. Question 12, the house is 10 metres above the water level. If the water is rising by 50 millimetres per year, how long until the water reaches the house? So again, let's start by putting things into a common measurement unit. So we're dealing with metres here, and we're dealing with millimetres for the water rising. So we can go to either direction. Let's put our chart up and decide which way we might go. So to go from metres into millimetres, we're going to multiply by 1,000, so 100 plus another 10, so that's the same as multiplying by 1,000. If we want to go the other way, we're going to divide by 1,000. Really doesn't matter. The multiplication is a little bit easier to do in some ways, but it'll give us bigger numbers. So it just depends which way you'd like to go. I'm going to start by going with, I'm going to go to millimetres, okay? So if we want to turn 10 metres into millimetres, we're going to have that equal to 10, and I'm going to multiply by 1,000, so I'm going to add 3 zeros on, so that's equal to 10,000 millimetres. Okay, so 10,000 millimetres, and it's going up by 50 millimetres. So this is a situation of division. How many 50 millimetres are in 10,000 millimetres? That's going to tell me how many years it takes. So if I do 10,000 divided by 50, okay, so I've got 50, can't go, can't go, can't go. So then 50 into 100 goes twice, okay, with nothing left over. And we're basically going to go and put a 1 and so there's nothing left, so we're going to keep putting zeros in there, so we end up with 200. That's what we're saying here is going to be 200 years for the water to reach the house. Now, could we have done that some other ways? Of course we could. We could cancel out some zeros to make the equation a bit smaller. We could certainly go from 50 millimetres into 10 metres, but at first glance, the quickest way is to convert your metres into millimetres and then do a division that we've done here. Question 13, another worded question. Australia is moving at a rate of 10 millimetres per year. How long will it take to move 5 metres? So this is very similar to the previous question. As in most of these questions, the most critical part is to convert them into a common measurement format and then work out what the equation is. So again, I'm going to take the 5 metres and turn it into millimetres to match this part of the question. So if I look at my graphic here again, to go from meters to millimeters, I'm going to multiply by 1000. So 5 meters is equal to 5000, because it's adding zeros on, 5000 millimeters. So now I have a situation like the previous question where I want to work out how many lots of 10 millimeters in 5000 millimeters. So again, I've got 5000 divided by 10. So I can't do 10 into 5, that's nothing technically. 10 into 50 now is going to go 5 times with nothing left over. So I'm end up going to just put 2 more zeros on there to round out my equation. So now what I've got is it's going to be 500 years for the water to reach the house. And that is the end of our examples. As we said earlier, in most cases, the most important part of this is to convert your units of measurement so that they are the same, remembering to actually convert your numbers to do so, and then it's about working out what sort of equation you are doing. Have a go at these. Again, come back and rewatch the examples if you need to.